Let's remember together the ideas learned in the previous session. We learned that there are two kinds of speed. Average speed, which is the total distance covered in a total time, and instantaneous speed, which is the speed at a specific instant. We also discussed one type of motion, uniform motion. Uniform motion is when average speed is equal to speed at different instants, or when a constant distance is being covered during specific interval of time. The cyclist reached a distance of 10 meters after 2 seconds. Then 20 meters after 2 seconds. Then 30 meters after the next 2 seconds. In the first 2 seconds, he covered 10 meters. In the second 2 seconds, also he covered 10 meters. And also in the next 2 seconds, he covered 10 meters. He is covering a constant distance of 10 meters every 2 seconds. The motion of the cyclist is uniform motion. In this session, we will discover the other types of motion. Please open your booklet, worksheet 4, page 9, part 2. Please, I want from you to correct the values of distance in the table and the values of instants of number 2 as follows. After that, pause the video, solve numbers 1, 2, and 3, then continue watching to check your answers. Number 1. Calculate the average speed of the cyclist. Using the formula, average speed is equal to total distance divided by total time. The total distance covered by the cyclist is 62 meters. The total time taken by the cyclist is 3 seconds. So 62 divided by 3, the answer will be 20.6 meters per second. This value represents the average speed of the cyclist. Number 2, calculate the average speed between instants t1 0.5 seconds and t2 1 seconds. To calculate the average speed between two instants, we use the formula d2 minus d1 over t2 minus t1. At t1, distance d1 is 5 meters. At time t2, distance d2 is 12 meters. So 12 minus 5 divided by 1 minus 0.5, the answer will be 14 meters per second. We use the same method to calculate the other values of average speed. Is the motion of the cyclist uniform? If you look at the average speeds calculated, you will notice that they are not equal. This means that the motion of the cyclist is non-uniform motion. The motion of an object is said to be accelerated motion when the speed of the object increases with time, and it is said to be decelerated motion when its speed decreases with time. Is the motion of the cyclist accelerated or decelerated motion? Accelerated motion. When comparing the different values of the speed calculated, we notice that the speed is increasing with time. Thus, the motion of the cyclist is accelerated motion. Pause the video again, solve part 3, worksheet 4, then continue watching to check your answers. Is this motion uniform? For a motion to be uniform, the speed should be constant with time. In this graph, the speed is not constant with time. Then no, the motion is not uniform. Is it accelerated? For the motion to be accelerated, the speed should increase with time. This graph shows that the speed is not increasing with time. Then no, it's not accelerated motion. Give the name that describes the motion decelerated motion, since the graph shows that the speed is decreasing with time. As a conclusion, non-uniform motion is of two types: accelerated motion, when speed increases with time; decelerated motion, when speed decreases with time. We have seen how to indicate the type of motion by referring to the speed. Let's see how we determine the type of motion by referring to distance covered during a specific period of time. The table below shows the distance traveled by a cyclist as function of time. At time 1 second, the cyclist is at distance 5 meters. At time 2 seconds, he reached a distance of 10 meters. So, he covered 5 meters in 1 second. He continues moving to reach a distance of 20 meters. From 10 to 20, 10 meters are covered in 1 second. He continues moving to reach a distance of 32 meters. From 20 to 32, 12 meters are covered in 1 second. The cyclist covers 5 meters in the first second, 10 meters in the next second, and 12 meters in the next second. Different distance is covered during equal interval of time. This means that his motion is non-uniform motion. Since distance covered every 1 second is increasing, 5 meters in the first second, then 10 meters in 1 second, 12 meters in 1 second. This indicates that his motion is accelerated motion. Now, let's solve together the application page 10 worksheet 4. Observe the graphs, then indicate the type of motion in each case. Before indicating the type of motion, you have to pay attention to the responding variable in each graph, whether we are measuring distance with time or speed with time. Let's check this out. We have these two graphs. The first graph measures distance with time. The second graph measures speed with time. What do these two graphs imply? Let's see. The cyclist was at distance 10 meters, for example. With time, he is still standing at the same position, at distance 10 meters. This means that the distance is not changing. So, the speed of the cyclist in this case is 0. The cyclist is not moving. He is still standing in the same position. Thus, the two graphs show that there is no motion. Let's see these two graphs, starting with the first graph. Using numerical values, at time 1 second, the cyclist is at distance 10 meters. At time 2 seconds, the cyclist is at distance 20 meters. So, 10 meters are covered. Then, at time 3 seconds, he reached 30 meters. From 20 to 30, another 10 meters are covered. So, every 1 second, the cyclist is covering 10 meters. This means that the cyclist is moving at a constant speed. Thus, the motion of the cyclist is uniform motion. So, when the shape of the graph, distance versus time, is straight increasing line, this indicates that the type of motion is uniform motion. We still have two other graphs. What is the type of motion shown in this graph? We are measuring speed. Speed is increasing with time, so the type of motion is accelerated motion. What type of motion does this graph represent? We are measuring speed with time. Speed is decreasing with time, so this graph shows decelerated motion. Now, I want from you please to pause the video, review the different shapes of graphs, then solve the following application. For each question, read it very well, pause the video, answer the question, then continue watching to check your answer. And here is the last application for this session. The distance of swimmer A at time 30 seconds is given in the table 60 meters. The graph represents the speed of swimmer B with time and not the distance covered by him. In this case, we have to calculate the distance at time 30 seconds. To calculate the distance, we have to multiply the speed by the time. The speed of the cyclist at time 30 seconds is equal to 3 meters per second as shown in the graph. So 3 meters per second times 30 seconds, the answer will be 90 meters. So the distance covered by swimmer B at time 30 seconds is 90 meters. By comparing the two values, the distance covered by swimmer A, 60 meters, is less than that covered by swimmer B, 90 meters, at time 30 seconds.